Okay, this is Dr. Williamson, and I'm going to go over the meaning of standard deviation. Standard deviation comes from when you take a bunch of measurements of something and you want to know how spread out your measurements are relative to the average or the mean. So in our example, when we're popping popcorn kernels, we took a bunch of popcorn kernels, we popped them, we determined the percent mass lost, and then we calculated the average of the percent mass lost. Then we calculated this thing called the standard deviation. If you get a small number for standard deviation, that means all of your percent mass lost were clumped up really close to the average value. So percent small standard deviation means all of your measurements were clumped up tight near the average. If you have a large standard deviation, it means your measurements were all spread out from the average. They're not clumped up tight to the average. Okay, so standard deviations is a measurement of the spread of your data points. Small standard deviation means all the numbers are really close to the average. Large standard deviation means the numbers are really spread out. You have a lot of variation. And one standard deviation right here, okay, whenever you calculate that, if this is your average, 68.3% of your measurements are within one standard deviation. 95.4% of your measurements are within two standard deviations of the mean, 1, 2, or 1, 2 below. And 99.7% of your measurements will be within 3 standard deviations of the mean. So if you calculate your average percent mass lost, and you find a standard deviation, and then you have a measurement that is 2 standard deviations away from the mean, that means it's way out over here. And that popcorn kernel was quite a bit different than the average popcorn kernel. And then sometimes you will see standard deviation calculated with either an n right there, or an n minus 1. This particular formula is if you measure the entire population of something. This formula is used when you take a sample of the population. So if I were to take the entire population of RCC female students, and I were to measure all of their heights and then calculate the standard deviation, I would use n because I calculated using the entire population of all of RCC's female students. And let's say that's 2,000 students. If I were to take a sample, like, okay, I can't get all 2,000 female students to line up and let me measure their heights, I'm able to get 500. That's a sample of the population. Then I would use this formula for this standard deviation calculation. Okay, so again, standard deviation measures the spread of your measurements relative to the average. Small standard deviation means your numbers are really close to the average. Everything's close to the average. High standard deviation means you have a really large amount of variation around the average. 68.3% of your measurements will be within one standard deviation of the average. Within 2 standard deviations will be 95.4%. Within 3 standard deviations will be 99.7%. Okay, that's just the basic meaning. This can be applied to any set of measurements. Okay, I hope that helps.